Hey guys, in this video, we're going to be talking about applying the alternate limit definition of derivatives. So this is similar to the limit definition we just covered, but that definition gave us the function of the derivative. So any input into that function would give us the slope at that point of the original function. This limit definition, the alternate limit definition, only gives us the slope at a certain point c. So it's going to be very similar as far as plugging things into the limit definition, but you need to make sure you're using each one of them properly. So in this case, we have a function x cubed plus 2x plus 1, and they give us a certain point that we want to find the derivative of, f of 2. So the derivative at c equals 2 is what we're looking for, so we know that we need to use the alternate limit definition. So let's go ahead and plug things in. When we're looking at this, our c value is going to be right here. So whatever point they want you to find the derivative at is going to be c. And f of x, that's just our regular f of x function. So let's go ahead and evaluate this. Let's start by rewriting. We want to find the derivative. At this case, c is equal to 2. So we're going to take the limit as x approaches c. So note that's different than the regular limit definition where we have delta x approaching 0, right? We have x approaching c in this limit definition. And let's go ahead and leave f of x the same for our first one because we're just looking at f of x. So that's x cubed plus 2x plus 1. And then f of c, we're just going to evaluate f of x at the point 2. So 2 cubed plus 2 times 2 plus 1, all over x minus 2. So let's go ahead and simplify this. And in this case, we can go ahead and substitute c in for 2 now. So let's distribute our negative, and let's go ahead and evaluate the 2 cubed and the 2 times 2. So let's rewrite our x cubed plus 2x plus 1. And now we have a negative 2 to the third power would be 8. 2 times 2 is 4. Distribute the negative would be minus 4. And then plus 1, distribute the negative would be minus 1. All over x minus 2. So let's go ahead and combine up our like terms, and we can kind of ignore this parentheses now because there's nothing that we need to distribute for the other one. We can just evaluate all in one go. So we have a 1, negative 8, negative 4, and negative 1. Those are all constants, so we can group them together. And we don't have any other like terms in the denominator, so we'll just leave it at that. So we have x cubed plus 2x. Our 1's would cancel out, and then we would have minus 8 minus 4 is negative 12. All over x minus 2. Now this is probably where a lot of people would get stumped with this problem, and that's why the alternate definition can get a little bit tricky, is because if you have something that's not easily factored, for example, our x cubed polynomial here, you might get a little bit stumped. What I would do here is use polynomial division, and then I'll see if we have a nice even remainder. What I would do is use polynomial division and see if we end up with a factored term and cancel out that x minus 2. So this might require a little bit of review from algebra, so let's do it step by step here. We would put our x minus 2 on the outside of our box, and our x cubed plus 2x minus 12 on the inside. We want to divide our x cubed by x, so x cubed over x would give us x squared, and that's what we place on the top here. And then we distribute that to the x minus 2 part, so x squared times x is x cubed. X squared times negative 2 is negative 2x squared. And we're going to subtract that. So if we evaluate this, the x cubed minus x cubes cancel out. That negative gives us a positive 2x squared. And we would want to bring down our 2x and our minus 12. And repeat that whole process. So 2x squared divided by x would give us 2x. We distribute that to the x minus 2, and we get 2x squared minus 4x. We subtract that. Those cancel. We get 2x plus 4x would give us 6x. Bring down the negative 12. 6x divided by x would give us 6. Distribute that would give us 6x minus 12. We subtract that, and our signs would flip, and we would end up with a nice 0 remainder. So this value is what would be left once we divide x cubed plus 2x minus 12 by x minus 2. So we can rewrite our limit now using that limit as x approaches 2. Now we just have x squared plus 2x plus 6. And this looks a lot nicer because we can go ahead and plug in 2 and not worry about having a 0 in the denominator. So we can evaluate our limit by plugging in 2, and we would get 2 squared plus 2 times 2 plus 6. So that would be 4 plus 4 plus 6, which would give us 14. Awesome. Let's go ahead and do one on your own. So we'll do f of x equals 4 minus x squared for c equals 3. And this is another format you might see it in where instead of giving you f prime of 3, they'll say c equals 3. So make sure you're aware of any different ways that they can give you the type of question where you would use the alternate limit definition. So go ahead, pause the video, and see if you can figure it out on your own, and then we'll go through it together. All right, our first step is going to be to rewrite this. We're looking for the derivative, specifically at the point c equals 3. So that's going to be the limit as x approaches 3. We're going to start by taking f of x and just putting that in our numerator. So that would be 4 minus x squared, and then subtracting f of x at the point 3. So we'll substitute 3 in for any x's we see in f of x. 4 minus 3 cubed. And this would just be applied to the 3 here. And then on our denominator, we would have x minus 3. Let's go ahead and simplify this by, we want to combine our inside parentheses terms and then distribute that negative sign. So we would just have our 4 minus x squared here. 3 squared would be 9. 4 minus 9 would give us negative 5. And then we distribute that negative, and we would end up with a positive 5. On the denominator, we still have x minus 3. Now let's go ahead and combine our like terms. So we have a 4 and a 5, and then our x squared we can't really do anything with. So we'll just rewrite the limit as x approaches 3 of 4 plus 5 is 9 minus x squared all over x minus 3. Now here's a pretty important turning point in the problem. Because if you're going to be successful with this problem, you're going to have to realize that we're actually working with a difference of squares in the numerator. But most people would recognize this better if it was written with a negative 1 divided out. So if we go ahead and divide negative 1 out and rewrite this, it would look like negative times x squared minus 9. And that might look a little more familiar to people who are used to working with the difference of squares. We can go ahead and factor this difference of squares by doing x plus 3 and x minus 3. And that's going to be the key to solving the rest of the problem. If we were to plug in a 3 for x right now, we would end up with a 0 in the denominator. So that's why it's important to be able to either factor it or to use polynomial division like we did in the problem right before this. But once we factor it, we'll see that we are going to be able to cancel out that x minus 3 binomial, and we'll take care of that problem in the denominator, and we'll be able to plug in our 3 for x. And now we just have negative x plus 3. So we'll go ahead and distribute that negative. Of negative x minus 3. And then finally, we'll be able to evaluate by plugging in 3 for x. And we will have negative 3 minus 3 gives us negative 6. And that's going to be our slope of the function 4 minus x squared, specifically at the point c equals 3. Thank you for watching. I hope this helps.